Well, hello and welcome to another DevNation. We got a lot of things to show you today. We're going to be moving fast, and I'm actually very excited because we have some really great content. I'm going to share my screen now, but I'm also going to paste in a link to the slide deck so everyone has it. And I'm going to share my screen where we can see it. And I'm going to show you what the agenda is for today. Okay, so we got a lot to cover. Let me get started here. And here we go. All right. So we're going to talk to you today about Quarkus, our supersonic subatomic Java. So Quarkus.io is the website. You're going to hear from myself today. You're going to hear from Jason Green and Edson Yanaga. And so we're going to rock and roll really fast. You're going to actually see a few slides up front, but we're going to spend most of our time in live demonstrations. Jason's got some really awesome stuff to show you with the live reload, how you actually set up a new Quarkus application. Edson's going to show you about how to connect to a database and build database applications. I'm going to show you some serverless stuff, as well as really fun interactive applications. So if you stay around to the end, I have an application that I've built that I'm going to actually let you also test with me live in today's session. So we have a large number of you today, so just be prepared for that. Do throw your comments and questions into the chat tab and make sure you get access to this link in this deck. As a matter of fact, I can see if you're connecting now. There you go. Look, a whole bunch of you started to connect at this point. So we're going to get you guys connected to the live deck. So one of the things I'd like to start off with when it comes to Java in general, because people are asking us all the time, why are you doing this for Java? Why are you bothering doing anything for Java? I've had that direct question. Why did you make an investment in Java? And so I like to say that the reports of my death are greatly exaggerated. This is my Mark Twain Duke here. As a matter of fact, we've been talking about Java as being dead for almost 13 years now. This is the oldest reference I could find to it, but at this point, it's kind of an old joke. Java is certainly not dead. Java is doing incredibly well. As a matter of fact, Java is still the #1 language on the TOBE index. It is still up there in the top 3 for RedMuck. It's still in the top 2 for HackerRank. So Java is doing incredibly well. So for all those folks out there in the audience who are like, why would you do anything for Java? This is why. It is a multi-million user base. It is my heart and soul where I come from and where Edson comes from and where Jason comes from. So we are super excited about Java and the Java language, and we want to make it better, faster, stronger. Okay, so Java, the reason Java has been so successful, though, there's so much goodness in its ecosystem. There's so much capability in terms of tools and frameworks as that you could have as far as utilities and frameworks and tools that you have in the Java ecosystem that you know and love. So we've taken full advantage of these things, and we use them throughout our daily lives as a Java developer. And there's a challenge with that, though. With so much to consume, Java kind of has put on a little bit of weight, okay? So this is really where Java has put on some weight, not Java, the programming language per se, and not even the JVM, but all the frameworks and technologies that sit above that really are where some of the challenges lie. So a lot of great flavors out there. You can have my nice donuts and some nice ice cream there, but so many flavors to consume, and things get notably tight, if you will, noticeably hard or heavy when we put that Java in a container. So if you think about a Linux container or Docker container, when we put that Java in there, things can get a little bit hard, especially when we actually lock them down. We want to constrain the resources associated with a container, which is what you normally do in a container environment with Kubernetes, etc. And then Java blows up. So we have a whole blog post on this concept. It's been known for quite some time that if you just put Java in a container by default with Java 8 and you don't do anything, it'll blow up by default. It'll consume too much memory, it'll consume too much CPU, and actually get shut down. So you'll see the out of memory killed message often in a Kubernetes architecture when it comes to running Java. And I also have these great quotes here because I was thinking about the serverless problem and I was Googling around on the internet and I found this great Reddit section that basically we were talking about, well, what about Spring Boot for Amazon Lambda? What about using Java for Amazon Lambda? You can kind of see some of the quotes here, right? You know, a lot of modern Java frameworks assume that memory is abundant and cheap, which it is not in a serverless use case, in a Lambda use case. So that's the other thing to keep in mind here. When you're dealing with containers, when you're dealing with serverless, when you're dealing with microservices, you are in constrained environments, highly constrained environments. You don't have a ton of memory. You don't have a ton of CPU. You actually get slices of each. You don't get the whole thing. So, you know, the big problem with Java, as you can see down here at the bottom, is in Lambda's startup time. Cold start time is a problem for Java. And so we actually heard these messages. We saw these concerns, and we were thinking about these problems. We want to make sure that we address them. You're going to see this specifically in Jason's presentation. Okay, so meet Quarkus, our supersonic Java. This is what we've been working on. So who is this Quarkus and what is all this fuss about? You can kind of see we made Java smaller more agile, much faster, okay? So it's up to 10 times smaller, it's up to 100 times faster. And so we've also focused on the developer aspects of this, meaning we wanted to focus on the developer joy. You're going to see that instance presentation. So the live reload capability, the imperative and reactive programming model, Jason's going to show you that in a second. I'm going to show you some of the serverless aspects as well and see how we run it with Knative on a Minikube and on my local machine. Definitely focused on microservices. It supports both fat jars as well as native executables, meaning you can run it in a JVM, straight up JVM, or an actual native executable binary that you'll see that live in action today too. Optimized for your traditional enterprise use cases like JAX-RS and JPA. That's a good example. And we certainly are focused on Kubernetes love, Kubernetes native. Okay. Now, a couple quick slides here on the performance characteristics. We're actually going to show you these things, so you don't have to just read these slides. But you can kind of focus on the concept here of being vastly smaller in terms of RSS, right? So that is the total memory footprint for that component, not just heap, but total memory. So we're gonna show you we can reduce the total memory footprint for that component. You can see like 13 meg here versus 140 meg. And even if it's a database application, which is very common in the Java enterprise world. So again, a subset of overall memory for that Java database application. And even the first response time. So forget about lazy loading. We don't really care about the fact that things eventually load. We care about the user's first response. And a serverless architecture, that startup time, that cold startup latency really, really matters. So we worked really hard on first response time. Okay, so all those things are in there, and you're going to see those. A lot of the magic that makes some of this happen is related to Grail VM, meaning you can actually use this technology, and we use this technology to take our technologies, everything you need for the Java virtual machine, your application, and all the frameworks that you depend on, compile it down to native executable. So you're going to see that live in action in our presentation also. And just one last bit about Kubernetes orchestration. Okay, that's really what our focus has been, is how do we make Java vastly, more superior in a Kubernetes architecture? Because I have personally seen a lot of people who are like, we're rewriting parts of our application, our microservices, in Node.js because Java's too fat and slow. I've run into people who are like, no, we're rewriting parts of our microservices in Go because Java's too slow. And so we didn't want to live in that world any longer. That's the problem we want to solve. So in the case of Kubernetes, you can think of it as the master node here, as well as these worker nodes. You can think of your individual containers or pods, as we call them, running across those different worker nodes. And you can think of how we schedule those things, right? So the whole point of Kubernetes is to run your application component in a pod. That's the computer the application is running on. And it's going to scatter those things around a series of worker nodes. And you can see the replica count here on my slide. The idea is it's going to have 2 of those running at all times. And it takes that declaration and runs them for you, right? So basically, Kubernetes is doing your Docker run for you, if you're familiar with Linux containers. Okay? And you can kind of see what happens in a world where we might have another component, but watch it. See the X show up here. What if that component dies? So Kubernetes is not only going to take your replicas and run them across your cluster, it's going to see that if anything dies, it's going to bring it back to life for you. So it's actually going to verify that that thing is now no longer live and ready. Those are the 2 probes that you see in a Kubernetes architecture. And then it's going to send it over to another node. Okay. And then like if you look at my replicas 20 here, if we build that same application in Quarkus as opposed to some other solution, then you can now have many, many more of those. So the density really matters here. Okay, so just think about that as you see today's presentations and demonstrations. This is not the end, it's just the very beginning. So at this point, I want to turn it over to Mr. Jason Green, who's going to rock and roll with us and show us some really good stuff from a getting started perspective and how to stay running perspective.
Okay, thank you for the awesome introduction, Burr. I'm Jason Green. I'm I'm the co-founder and co-lead of Quarkus, and I'm going to show you all about how you get started with Quarkus. Now, as Burr mentioned, Quarkus is all about making your Java applications incredibly efficient, but it's also about saving you time and energy as well. And so we've had a guiding principle, which is developer joy. And by that, we mean that we put the developer first and foremost in every single thing we do. So to start off, it's really easy. You simply go to quarkus.io, the website, you go to the Getting Started guide, and you can simply cut and paste a Maven command. So it uses a Maven archetype to generate your project for you. Now, once we have our project, we can fire up our IDE of choice. You can use anything that you want. Quarkus is designed to work out of the box with just about everything. So I've got my IDE going. I'm using VS Code at the moment, and I'm going to go ahead and do my first operation, which is I'm going to do my live development mode. Now, with my live development mode, I can make any kind of Java change that I want, and I don't have to worry about constantly rebuilding with my Maven commands or running some special IDE program. I simply just start in live development mode. And it starts pretty quickly, under a second right here. So we're going to go and we're going to take a look at what we created with our archetype. So the first thing we see is a simple greeting resource. Now, I probably should pull up, just to make sure everything's working okay, I should probably just go ahead and take a look. And you can see right now there's a splash page, which just gives you some useful information. But what we've written right here with our archetype is we've created a REST endpoint, and it's going to respond. So this is our HTTP microservice, and it's just going to respond with hello. So let's quickly take a look at that and see if that is working correctly. And I can make that a little bigger for you. And as you can see, hello. So, okay, let's take a look at this live reload capability in action. So I could simply say, instead of hello, I'm going to say, hi there, and see what happens. So all I have to do is just refresh. Well, if I type in the URL correctly. There we go. Well, now to prove you that it actually did work, I'll say hi there again. And I did the same thing. Refresh. Okay, one more time. Okay. So of course, you could do this with just Java debug mode, right? So this isn't really that fancy. So let's do something a bit more complicated. So normally you don't want to have a constant string. You want to do something a bit more like a normal application where you would externalize something into a resources file. So one of the things that Quarkus supports is built-in injection using CDI annotation. So I can say inject, and I'm going to pick a configuration property using microprofile config, and I want to say my configuration name is greeting. All right, so now if I go into my resources here, all I have to do is define a greeting. And instead of hi there again, we're going to say what's up, doc, and see what that looks like. Okay, and I think I must have made a mistake. Ah, yes, I did not return my greeting variable. It was actually kind of cool. I should show you guys with the hot reload capability. You can actually, so we'll go ahead and refresh this, and you can see what's up, doc. You can actually make a syntax error. So I'll just do that real quick, and then I've got an error. And then I can correct my error and simply reload that again, and that'll work correctly. Okay, so I've externalized this variable. Now, one of the things is that testing just works out of the box, so it's just nothing special. There's no special plugin to install. So if I click my test function, I get an X. And why did I get an error? Well, I got an error because I changed the message. So the test was originally expecting hello, and what we really wanted to say was what's up, doc. So we'll go ahead and correct that real quick. I can rerun the test, and then as you can see, the test is going to then pass right away. But we want to do a little bit more than just this, right? So let's take a look at how we add additional capabilities. All I have to do is say list extensions. And I get a nice little list of all the extensions that are available. And this is something that we're adding to all the time. We're releasing in about 2-week intervals. So let's go ahead and add an extension. So all we have to do is cut and paste this command right here. And which ones do we want? Well, I'm going to show you some reactive because Quarkus allows you to do both imperative and reactive processing. So I'm going to do streams operators for that. And then I also want to do let's do some JSON. So we're not just doing simple hello world strings. So we'll take this JSON B extension, rest easy JSON B. And away we go. So we've added the extension. Now we can rerun our dev mode again. All right, so now dev mode is currently running. Okay, so let's get back into our resource. And now, like I said, you can make any Java change. So in this case, what I would like to do is I would like to create a new file. I'm going to create a person class. And in this person class, we are going to give it a few fields. So let's say name. And we'll say, let's give it an age. How about that? And then we need a constructor. So and then, of course, initialize some fields. I probably should install a VS Code plugin that does this for me. There you are. And then from here, I can generate some getters and setters. But I don't have to do a default constructor or anything like that. And okay, so I've now created a whole new class called person. And then in my resource, all I need to do is I'm just going to copy this method right here. And I'm going to return JSON. There we go. Okay, so we'll say hello person. And instead of a string, we need to actually return a person. And let's do that. So new person, and we'll say this is John Doe, pick an age, 25, say. And because we have two methods that could possibly respond to a REST endpoint, we need to actually give a different location. So we're going to say /person, just like that. Okay, so I just hit save, and then and all I have to do is just go to the new location. So we'll say /person, and we get our JSON message right there. So you can see age 25, name is John Doe. So that all works great. Now I promised to talk to you about reactive. So we're going to do something a bit more interesting. And with reactive is all about being able to handle a massive amount of data and being able to do things without blocking threads. So it allows you to achieve greater performance. Although with Quarkus, we support both imperative and reactive. And the idea is that we really want to help you use the best tool for the job, so that you're not trying to, end up trying to force everything to be reactive. You don't have to force your entire technology stack to be reactive. You can simply use the methods that you choose. So in this case, we're going to do a reactive version of our message here. And so the first thing is let's rename this method. So we'll say hello async for that. We're going to need a new path as well, so we'll stick that on async. Now, one of the things is that when you use reactive programming, there's a few different methodologies that you could use that are supported with Quarkus. And in this case, I'm going to use what's called a completion stage. So, and this is a standard Java concept from Java Util Concurrent. And what completion stage is all about being able to process data and it is running and then return before that data is completed. And then at a later point, you can fetch that data. So kind of like a future. So in this case, I'm going to say return reactive streams. This is using microprofile reactive streams. And I'm just going to do something simple. So I will do hello with a string. So this is just like normal standard Java streams that you already use for normal like collection processing. And instead, it's connecting it up to I/O for you. So I can say hello, and then I'm going to do something interesting. So I'm going to make this uppercase. So I'll map my string to be uppercase. And then I'm going to create a list out of that. And I need to run that action. So I've prepared my operation. I'm going to run it. And then after that operation completes, I would like to do another function. And this function is going to convert my list to a string so that I can then return it. So we'll do that real quick. Okay. And there, so that looks like that's correct. So hello async returns text plain and completion stage, and that's it. So let's go ahead and change this return. Oh, I made a mistake here. Oh, look, see the compilation error right there? So we'll just go ahead and fix that. And we will reload. And there we go. So we've actually streamed all that data together and returned that list concurrently. And now I'm going to change this a little bit so I can do all kinds of operations. Any type of stream operation that you work with in Java, you can do. So we'll use distinct, and this will ensure there's only one of any given character. So as you can see, it's HELO instead of the two L's. Okay, great. That's interesting. But there's another style of streams, which is a publisher subscribe model. So let's take a look at that. So things are going to get more interesting. We're going to create a new file here, and we're going to create something called stream bean. And stream bean is going to use our injection annotations again. So let's create the class, and we're going to have a counter. So we're going to use another concurrency thing. We're going to use atomic integer, and we'll say counter is new atomic integer. And then we're going to create a new stream method. So this will say publisher. Also going to return a stream of strings, basically. So we say stream. And in this, instead of using reactive streams, we're going to use what's called a flowable, which is part of ReactiveX Java. So the flowable is a nice construct because it allows you to generate events. So we're going to generate on a 500 millisecond interval. We'll say time milliseconds. Let's have an error or something. Oh, I need to import this. That's why. And there we go. Okay, now so every 500 milliseconds, we're going to return a value, and then we want to map that. So we're going to convert the time so the interval that's returned. We're going to generate that into a counter value, and then we're going to say increment it. So we're going to increment by 1, and then we need to convert that to a string. So the counter value that gets returned, let's convert that to a string. And finally, actually, that should be it. That's all we need to do. That is our stream. Okay, so let's go back to our we do want to make sure that it's available for injection. So when you're using CDI annotations, you could declare something as application scope. That makes it available for injection, and that means there's going to be one instance for our whole application. So in our resource, we need to eject that bean. So let's say add inject, and then we're going to say it's a stream bean. And then we can create a new method. So we're just going to copy this async version. And we'll call it stream. And we'll say instead of hello async, hello stream. Now we want to use SSE, so server sent events, to send this back. So we're doing a full continuous stream. And instead of returning this reactive streams call, we could simply just run our bean.stream method. We're going to fix our return type to match, so it's a publisher. And that should be it. So let's fire up a terminal and we'll use curl, just go ahead and connect to the web server. And we'll say hello and string, because that's our URL. Oh, looks like we have an error. Oh, yes, so no semicolon. But as you can see, every time I do this request, it's actually recompiling, rebuilding my application. Now I have a stream of data that's coming in. You can see it counting. So that's every 500 milliseconds, it's generating a new index from that counter. All right, so now that you've seen that, let's take a look at actually how you build an application. And by the way, that exception is because I'm aborting the client, and so it's just the fact that the client hangs up, it triggers an error. Okay, so now from here, I'm going to do, just like you do any other Maven program, so do Maven compile package. And then once I get my application built, so test ran and everything, from here I can just take a look. Let's take a look at what was created. So as you can see, only 47 kilobytes is the size of the actual runner jar. And there's a separate lib directory with its dependencies. So this just allows you to have clean separation so you can do layering and so on. And I'm going to do java-jar target, and then I'll just use my runner. So getting started. And it's running. I should verify it's still working so I can run my command over here and the stream is still functioning correctly. Okay, oh yeah, and actually I forgot to highlight that when I do run this, it's starting really quickly. It's starting in about half a second, 0.635. So that's just using just plain OpenJDK. But things get really interesting when we start doing things in native images. So let's take a look at how we do that. So if you go into your project that was generated, there's a nice little Docker file. And in here, you can see commands to do this stuff. So all you need is just an nvm package command, but you pass it just a p native for profile native. And then there's a separate flag that you can either choose to build on your operating system you're using. So I'm using a Mac in this example, and that would have created a Mac executable, but I don't want a Mac executable. I want to run in a container. I want to run with Linux. So I use my Docker build option. And if I run that in here, I can then start that process. So this takes a bit because it has to do a whole bunch of generation. So I'd like to talk to you a bit about what actually Quarkus is doing. So let me move over to here, and let's make this a little bit bigger for you. Okay, so what's happening? So what Quarkus does is essentially it is a full advanced dynamic runtime container that has been transformed to move everything in build time. And how Quarkus does this magic is it actually transforms your bytecode of your application and performs a bunch of advanced heuristics to generate the actual code, which is then ran by a Graal VM compiler called native image. Because it produces optimal code for Graal VM is able to efficiently generate a very tiny native executable out of your application. And this native executable encompasses not just your application itself, but also the pieces of the JDK that you're actually using and the frameworks. So it'll be a very, very tiny binary that you can then put on a container and then run in very high density in the cloud. Now, the reason why this is important is because application environments that run Java applications, they deal with a lot of things like indirection. So you saw the fancy annotations that were in the application. You saw add get, you saw add inject. Well, this add inject has a decoupling. And because of the decoupling, a static compiler cannot necessarily know how to process that efficiently. So what Quarkus does is Quarkus resolves all of that decoupling into something that is direct instruction so that the static compiler can then produce that executable. Now, because this is a complicated thing to do, and because we want it to be easy to extend Quarkus and to add additional extensions, we built a whole architecture around making that easy and automated. So in the Quarkus core's whole responsibility is to generate all this magic for you. And then we have a layer of extensions which utilize that facility. And we emulate as if you're in a runtime environment. So your extensions don't have to do bytecode fanciness or anything like that. They just simply say, okay, register this URL, set this host, do these things, and then out comes an executable. So let's take a look at the executable that was generated. I can list my target directory again. And as you can see, this Linux executable is 22 megabytes. So that's everything. That's the actual native image of the application and the dependencies it's using and the JDK it's using. This is all you need. You need that and libc and libz, and you could run it on your application. All right, so now we're going to build a Docker image out of that. So let's do that real quick. Okay, so now we have a Docker image, and the next thing we need to do is actually run out. One thing is I like colors, so let me change this command real quick. So we'll get some color in here. Okay, so we run our Docker. And you can see it started in 0.004 or 4,000ths of a second, 4 milliseconds. And we're immediately available to answer requests. And that's incredibly important in a serverless architecture because the time that you take to start is added to the requests that you are processing. So it's very, very important that this be a very small number, and this is a very small number. So I can create a separate window here, and I can go to say hello stream. And you can see that our native application is serving requests running in a container. Now, let's take a look at how much memory is actually being used. So I can use a little script I wrote. Do that. Okay, so we're going to take a look at the actual RSS size of the process. And as you can see here, you were able to see. As you can see, it is 15 megabytes, which is incredibly small. That is tiny, and if when you saw the other slides that Burr was showing, there is a different density factor here. When you run a normal Java application, you typically use hundreds of megs, and in Quarkus, we're using tens of megs of memory and starting in blazing fast times. So we're talking about something that really transforms how you could use your application in the cloud. And with that, I'm going to hand things back over to Edson, who's going to show us how to take things to the next level and operate with data.
Here today presented to you something about Quarkus. Like 99% of the Java developers worldwide, they still need to touch a database when
Hey there. So if you're waiting for Edson to get back on, he is working on his audio right now. We're going to find a backup connection for him to basically broadcast audio in addition to his screen share. We can see his demonstration. So hold on 1 second. We'll be there.
We had some technical issues.
I'm still not hearing him.
Yeah, me either. I see me into that.
Yeah, now you're greeting. Oh, now you're red.
Okay, sound check. 1, 2, 3. Is it good? I hope it means that yes. Okay.
Yes.
So yes. Okay. So so you didn't hear me in the beginning, but what I really Jason presented awesome things about Quarkus, and well, Quarkus can run native, can start very quick, very fast, has a very low memory footprint, but it wouldn't be enough for us as Java developers if we didn't allow us to have a very quick inner feedback loop. So like 95, 99% of the Java developers worldwide need to interact with a relational database in their daily activities. So what I want to show is how joyful it is for you to play with Quarkus when you're touching a database. I have here on my machine MariaDB running. So if you look at my console, I have some databases here. I just created a database called SparkJoy. And if you go there and see, I have no tables available. And so right now I'm going to create a new Quarkus project with means SparkJoy. And if I go to this folder, I just want to be able to create that. And I just say mdn Quarkus, maybe I'm plugging. I want to pick a version and I want to create. Okay, so I can use the group ID, artifact ID, version. I want to create a new REST resource and just come Red Hat developer. Developer resource, because we're talking about developers, right? Developer resource and developer. Slash maybe. So I just created that, and let's open this project. While my ID is bootstrapped. Okay, importing. Let me switch to presentation mode. Developer resource. So it's basically the same endpoint that Jason showed to you. And maybe I want to change this to /developer. And if I just run it the way it is right now, it showed me the hello. Okay, no big deal here so far. We've seen that before. So let's try to touch something very interesting. So I need to install some extensions in my Quarkus project. So let me get back here. npm Quarkus list extensions. So I have the extensions. Let me try to add some extensions. And the extensions for today are, I want to add JSONB for REST Easy too. And I want to use Hibernate with Panache. I'm going to show a different way for you to access your database using Hibernate Panache. And I also want to use a database. So I'm going to add the JDBC driver for MariaDB. Okay, that should be enough. All right, I'm up and running, so I can go back here to dev mode, file Quarkus, dev. Okay, it's not going up because I didn't configure Hibernate yet, but we can go back to our IDE. I can show here. If I open my POM, you can see that I've added these dependencies, the JSONB, the MariaDB, and the Panache. If I go here to my application properties file, I know these properties by heart, but just because we had this technical issue, I want to go back here very quickly and copy paste the properties that I just configured before. I had a backup, and luckily I had this backup. So what are we going to configure here? I just have to add the properties of the JDBC URL, which is MariaDB running on localhost, and my new database, SparkJoy, that I just created. I also have the driver, the MariaDB JDBC driver, my username and password of developer. And I want for this interactive demo, I want to use the database generation equals to update, because we'll be just changing the code on the fly and also updating the database on the fly. So it makes a very nice experience. So if we go on here back to developer resource, if I did all that, it should be enough for me to start development. All right, now Quarkus is up and running. My hello endpoint still working. So let's get back to my code. So if I just go get here, and let's say I want to create a new entity. So let's try to create a new class. So I have a class called developer, of course, and developer. And since it's an entity, I'm going to annotate that with an entity. And if you're used to JPA development, probably you would think, oh, now you need to add an ID, getters and setters, and all of this stuff, mapping, but I want to use Panache. So if you want to use Panache, which is, think about Panache as Quarkus alternative to the active records pattern for persistence. So if you ever use Ruby on Rails, or if you ever use the Play framework with Java or Scala, it kind of has the same idea. So instead of having a repository, which by the way, Quarkus also allows you to do that. I'm just showing you a different way of doing the traditional stuff that you're used to. You could do that too. But so here we're using a active record style, and I want to add some property. And maybe I could create like private string name and generate the getters and setters, but with Panache, you don't even need to do that. You could just generate like a public field, and when we're compiling your code, we're just generating the getters and setters for you, so everything is going to be accessed through getters and setters. But for your code, you just need to declare a public property. Okay, and how does it work here for us? So if we want to have a developer resource, so instead of just returning real hello, maybe I should be renaming these developers. And I want to return application JSON, and I'll be returning a list of the developers available on my system. Okay, so and what do I need to do to return a list of all developers in my system? I just say developer, and I have a static method saying list all. Of course, you wouldn't be doing that in production, because if you had like 1,000 or 10,000 developers, you get a huge list to be returned. But since we're just playing here, we can list all because it's going to return everything. So if I just go to this endpoint and ask it for localhost developer, you see that it returned for me an empty JSON list. You can see that Quarkus only took 1.4 seconds to reload and to connect to my database, to create my database tables. Did it really create my database tables? Well, let's just check. Yes. Just create a developer Hibernate sequence, and if I try to describe developer, I can see, yes, I have an ID, and I also have a name. So Quarkus did that all the fly. I didn't have to stop anything. As soon as I saved my file, Quarkus was ready for me. So let's try to populate my database. And again, I don't have to change anything to stop anything or start anything. I just code. And that's what we as developers enjoy, right? So let's say I'm not creating a REST endpoint because then I would need to curl. I like to do everything on the browser. So let's try to get, I want to do a path/new, and maybe I want to add a name. So it's going to produce for me also media type.application JSON. And I want to I'm going to return a new developer. Okay, here I can receive the path parameter. It's going to be called name, and this string name, right? So how do I create a new developer and persist that on the database using Panache and Quarkus? I just have to create a new developer. Oops. Developer, instantiate that, and I say, well, the developer name is going to be .name equals to this, and now you can say the developer.persist and return developer. All right, it should be enough for us to be saving my entity. So if I go here back to my console and just say /new/Yanaga, oh, you can see that I've returned the entity that was just persisted. If I go back here to my database, I can see my database still here. Let's try to see what's available on my database. And you can see that there is nothing. And why is my database empty? Why is my table empty? Well, I made a mistake in my code. If you go back here, I'm just asking it to be persisted, but I didn't create any transaction. So I need to add this transactional notation here. And now it's probably going to work. And let's go back here. Let's try to persist a new person, Yanaga. And now if I select everything, yes, I'm being persisted. So you can see when you're developing, you're creating your new pieces of code in your application, maybe sometimes you make some mistakes. And instead of having to rebuild your application, taking like minutes for a build, and then another minutes for you to wait for application to get back on the stage that you were, well, with Quarkus, you don't need to do that. You just go to your code, you edit your code, you save the file, hit the browser, and it's already there. And that's my favorite feature about Quarkus. So what we just created a table, but maybe Quarkus can also add some features to our current instance. So yes, I add a developer. Maybe I could also add another field, public string like favorite framework. And of course, the favorite framework for everybody these days is Quarkus. So I'm just going to add this property. I just hit save. I just go back to my browser. Let's see what's happening with Quarkus here. It's so fast, I need to give it some time so you can see what's happening. And then just hit reload and try to save a new one. Let's try to put JSON here on my database. Yes, so JSON already has a favorite framework. This one is Quarkus. And if I ask it to show what's available on the database, you see, I have, on Yanaga, I don't have yet a favorite framework. We can fix that quickly on the SQL database, but JSON is available on my database and its favorite framework is already Quarkus. Just let me fix that because I think that's a huge mistake for me to not have Quarkus as a favorite framework. So let's say update developer, set favorite framework equals to Quarkus. Okay, and if I go back here, yes, now Quarkus is the favorite framework of everybody. What else can we do with just Panache? So you can say, I said that you can do everything as public fields inside your entity, but you can also do more. And what is this more? Suppose that when I say favorite framework, I don't want it is being persisted as just Quarkus, but when somebody retrieves that from the database and shows that to the user in a JSON format, I want to add some more information to this string. So maybe I could just create a getter. So when anybody tries to get their favorite framework, I can say it's not just their favorite framework. I could say that I can add some information. So I'm going to add a string. And I say that Quarkus is just simply coding that sparks joy, because that's my favorite thing. And if you're thinking about, oh, he's using that Marie Kondo reference, yes, shamelessly, just reusing that because I think it's very nice. So when I say coding that sparks joy, I just have to go here to my web browser, and when I ask this, yes, it's available there too. And it's not just for getters. We can also do that for setters. You see, I'm using public fields, but behind the scenes, Quarkus is using the getters and setters for me automatically. I don't have to touch anything. But suppose that every time I want to persist a developer, when I'm writing that to the database, I want that name to be persisted in lowercase. So yes, I can use a set name here and say that, well, name is going to be persisted as lowercase. But when anybody tries to retrieve the name, I want this name to be on uppercase. You see, very few changes in my code, setter and getter. I'm adding some business semantics in my code. And whenever I go here back, you can see that the name is already being returned uppercase, but it didn't change in the database yet. It's already camel case. But if I want a persistent new developer here, /new/Burr. So Burr, his name is uppercase here. If I go to the database, you can see that his name is lowercase. But whenever I try to retrieve the information, it's going to be all in uppercase. Okay, so you see, Quarkus is very fast and allows you for you to have a very quick inner feedback loop when developing, and it's simply for me, it's just spark joy every time I use Quarkus. And of course, Quarkus has a lot of more things to show to you, but now I'll leave it to Burr so he can show some other also something from Quarkus.
All right. Now I find the screen share button. And let's see if I can get a little inception going here like Edson had. Okay. So this was the slide deck we were working on. So hopefully you guys joined that and check that out. But now I'm going to show you some example applications that I have. So if you build on or think about building on what Edson just showed you and Jason just showed you, I'm going to show you a couple other things side by side. So already a bunch of key questions are, what about Spring Boot? What about Spring Cloud? I saw those. And so maybe some of this is your answer here. I actually have a Spring Boot application running side by side with a Go application. I also have my Postgres database, and I have a Quarkus application all running within my local Minikube here. And so that's what I'm using is Minikube. And so if I come up here, jump back here. If I come here and say kubectl get deployments, you'll see those deployment items there. All right. And then this is the pods that are running right here. And then I have some application code here. So I'm going to do a quick poller to basically hit the endpoint. Okay. And actually, let me open up the browser so you kind of see what this application looks like. So basically what we were seeing earlier. So here's the apple and the pineapple. I'll add a new fruit called Burr. Okay, and then so there's my 3 fruits there, and let me run my poller again. I'm just running a typical create, read, update, delete against a Postgres database. Again, it's all running within the context of Kubernetes, and I've already done my Minikube SSH over here, so I'm in Minikube. So let me see here. Let's actually look at the memory footprint for this Quarkus application. So this is about 50 megs with how I have it set up here. So about 50 megs of memory being used by this CRUD related application. You kind of see it's pulling away down here. If I come over here now and let's remove Burr. And there we go. Okay, so that's the Quarkus application. I also have a Go version of this, and let's look at the Spring Boot one. Again, they are different architectures, or sorry, different things, I should say. And actually, let's just look quickly at the code for the Quarkus one, because you were seeing it there with Edson. Okay, so it's just the standard stuff you saw with Edson earlier, except this is kind of a whole Hibernate-based application. Let me switch over here to the Spring Boot one. Not that one. And same thing here. Let's do the poller. All right, that's good. And let's open the browser for this application. So there it is. And so again, hit it there. I'm just testing it real quick, make sure. Let's add Edson as a fruit. Okay. So Edson is now fruit with our apple and pineapple there. There he is. And so if we look for that Spring Boot application, it's running as a regular Java application. You can say it's using about 260 megs of RAM there. So basically, about 5 times bigger. So that's a simple example of a CRUD-based application. And if we look at that app, you kind of see it's pretty standard, straightforward Spring Boot style application. No big deal there. That's the test. Let's see here. Again, there's the entity, and of course their controller. Okay, very standard stuff. So just to kind of give you that comparison side by side to give you a feel for what a real application looks like. So a lower memory footprint, faster startup. And in a Kubernetes architecture, it does make a big difference. But I want to show you a couple other things real quick. So let me do this. I'm going to switch namespaces. And this is not meant to be a Kubernetes introduction. Let's switch namespaces here. And so let's go into Node.js application. Now this time, what I have is not just a straight Kubernetes application. I have a Knative application. Okay, Knative applications behave a little bit differently. So I'm going to actually notice there's no pods running, but when I hit it with a large, with enough load, in this case, 20 concurrent connections, 20 concurrent users are being made, you can see that Node.js app scale up. You can kind of see it happening right there. And then let's see, get connected. So there it is. It just came up. And so it took about 19 seconds to get it going. And let me just run my poller there also. So with Knative, right, it's going to dynamically scale up from 0. And you saw that latency based on the first request, right? So the first user is having to wait for that thing to scale up and come to life. That's the nature of a serverless architecture. And then, of course, it does automatically start scaling down. It does see that based on my simple poller here at the bottom, that it only needs one of these pods running. So that's the beautiful thing about Knative running on top of Kubernetes. But the same mindset or the same concept works in any serverless architecture. But let me see here if I look at my Node app. Okay, and notice there's actually a bunch of results here. Notice the 3x3. So you have the two sidecars, both Istio and the Knative sidecar associated with a Knative-based app. And so that adds a little bit of overhead. But let's see, and you have to kind of look through here amongst the sidecars to find the actual endpoint. All right, so that's about 31 meg, all right, in RSS terms. So you can kind of see Node.js there. Let me come over here to Quarkus. Okay, same kind of thing. Let's see if we can burst it out. Hit it with enough load because the system to scale. And keep in mind, my system is actually pretty overloaded at this point. Not only is it doing the live stream, but it's also trying to run all those other applications you saw earlier. So there we go. It kind of responded pretty fast there. So it actually responded faster than the Node.js application. And often I see that. Let's look at the poller, and let's go check out its memory usage also. So there we go. And let's see if we can find its memory in here amongst all these sidecars. Dun, 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 dun. Let's see, right there. So 15 megs of RAM. So it's running about half the size of the Node.js application. So I make that point only because I talk to people all the time. They're like, well, we're rewriting our microservices or doing our serverless and something else other than Java because we need something that's smaller and faster. So what I just showed you right here is not only were we smaller and faster than Spring Boot, which is a fairly easy comparison, we're smaller and faster than Node.js as well. Okay, so I want to make that point. And I want to show you one last little demonstration, and then we're going to ask, we have a few questions. I have one other little fun thing I'll show you real fast. We don't have a lot of time for it here. Normally I'll do a little live coding on this as well, but I just want to give you guys a little cute application. It's actually a very simple application based on a WebSocket here. Okay, so very simple WebSocket code. It was one I used to do in VertX, but let's just run it real fast. And we'll let you, so you can see even on this Linux server, which is running up at EC2, it starts instantaneously. And what I want you to do is go to web.bur.red8080. Okay, so you do that in your browser. And actually, I'll even add it to the chat real quick. Boom. Okay, come back here. And let me go to my everybody here. Okay, so let's see here. Here's how this works. It's a simple little thing that I have fun with at different audiences. But now you can come over here and paint me a little picture. Okay, and what's cool is every keystroke that you drop in, you'll see that also immediately impacts my screen. So if I can hit clear, and if I can come over here and put my name in, so there's my tile that I'm working with right there. So you guys are doing a good job filling out my screen here. And so the point of this is mostly JavaScript on the front end with a WebSocket backend running through Java. But again, that small, simple application that I can build with Quarkus, I can basically push out very rapidly to the outside world. Okay, so we probably won't let you guys draw too many pictures because it could get offensive. But we do need to take some questions. So let me stop screen sharing now and get everybody back in here for some questions. And we'll get Jason and Edson back online here. And I'll read you out some questions I noticed during our presentation. So great question for you, Jason. When do you use JVM mode versus native?
That's a great question. So really the biggest difference is that with Hotspot, OpenJDK Hotspot, you get the, typically you get the best JIT performance because it can react to runtime code, whereas with native images, you're using ahead of time compilation. There's some like technical differences between the two. Largely, you know, I/O is the biggest factor when you're talking about things like microservices. Native images, on the other hand, give you that really, really small size. So typically, the way I like to think of it is if you have an application that has like gigantic heaps, then you know you're going to be more steered towards hotspot. But if you have an application which is like your typical REST microservice or event, say Kafka-based microservice or serverless application, then you're looking for a small footprint size. So you're looking for native image. And one last thing I'll say is that it's important not to think of things in just the term of a monolith. You can take something that you would normally have as a big JVM, and really to take advantage of the Kubernetes architecture, you want to have a whole bunch of tiny containers so you can scale up and scale down based on your load and needs and save those resources costs as expensive cloud resources.
Okay. All right, it's a quick question for Edson, if he's still on the phone there. So how would you compare and contrast this versus Spring Boot? There was like at least that question a dozen times. This is replacement, an alternative. Can I run Spring Boot? Can you give us a quick answer on Spring Boot versus Quarkus there, Edson?
Oh gosh, that's a complicated one. Right?
And you only have a couple moments. Yep, we can hear you.
Okay. Well, how do I say, as a long-time Spring Boot user, I can say that, well, for many use cases, they're equivalent. So the things that you could do in Spring Boot, you can also do in Quarkus. But I'm really excited. What I'm really excited about Quarkus is its capability to boot very fast, to have a very fast response times for first request, very low memory footprint, and I think I can attest that you don't get the same inner feedback loop response time with any other tool. So if you just save, refresh, you get the response. Quarkus is the best one here, but if you just want to create REST endpoints and access database, for example, I would say that they're equivalent.
Okay, and then a related question that we'll just address really quickly. People are asking about Spring Cloud specific annotations, like how to deal with service discovery, how to deal with circuit breaking, how to deal with load balancing. And that was a question by Mark. And so Edson, I know you kind of feel about the same way as I do, is with Kubernetes, you don't need most of those things. With Kubernetes plus Istio, you definitely don't need those things. Those things are part of the infrastructure now. So if you are building applications, microservices applications that require a lot of those capabilities, and you're living outside of Kubernetes, then yes, you'd still be interested in some form of discovery mechanism, load balancing mechanism, circuit breaking mechanism, bulkheading mechanism. But if you have Istio on top of Kubernetes, those things are solved for you already. The good news is it's just part of the infrastructure. We only have time for one more question. And so go back to Jason. So if I have an existing app of millions of lines of code, I saw that question in there and I thought it was kind of an interesting one. What does it mean to bring millions of lines of code into a Quarkus universe?
So I guess there's different ways I could take the question. I'll try to answer it fast. I'll just say right off the bat that if you're thinking of just trying to drop in, say, an older EE app and run it on Quarkus, that's really not what we're focused on. We're focused on new greenfield apps. However, it does carry a lot of the same support for a lot of the same APIs and frameworks that you may already use. So it should be very easy to port your use case as long as it's a microservice-based use case. If you're talking about, can you actually have a gigantic app and run in a native image with Quarkus? The answer is yes. We've done internal modeling and testing of very large applications. Although in general, the architectural paradigm of microservices is you want to have small services that are focused on separate functionality so that you get the best robustness and scalability of your system.
Okay, well, thank you so much for that, Jason. And we are out of time. There are some more questions, and please do hit us up on the chat. So you saw John actually post that information there about the chat. You also have access to the Quarkus website, and you have access to all of us on Twitter. You saw our Twitter handles when I showed you the slide presentation. So awesome stuff today. Hopefully you guys enjoyed the session. Thank you so much, Jason. Thank you so much, Edson.
Thank you, guys.
All right, everyone, we're signing off. Have a great day.